Alright, so welcome back. Hopefully you guys watched the vertical angles theorem. Now we're going to talk about the alternate interior angles theorem. And before we get to the alternate interior angles theorem, I'm going to provide you with a postulate. Now, postulates are, it's the idea about postulates is that they are truths that we know without proof, pretty much. So, for this postulate right here, first of all, I'm going to draw a diagram like we did before. So here, I'm going to draw my line right here. I'm going to draw two other lines. Right there and right there. So I'm going to call this line L and this line M. And they're cut by a transversal T. So this is like the diagram up here. Okay, now, again, I'm going to call this L instead of A, but L and M are parallel lines. So these two are parallel lines and they're cut by a transversal T. Now, if you remember from our diagram at the start, corresponding angles were in this case which ones were they? 1 and 5 in this example. So 1 and 5 were corresponding angles, but also 2 and 6, 4 and 8, and 7 and 3 were also corresponding angles. Okay, so I'm first going to give you the corresponding angles postulate, which states when two parallel lines are cut by a transversal, the resulting corresponding angles are congruent. The resulting corresponding angles are congruent. So this is just a postulate that tells you corresponding angles are indeed congruent. Okay? So for this example, I'm going to label this angle 1, 2, 3, and 4. I'm going to label this 5, 6, 7, and 8. Okay. Now, this theorem right here, the alternate interior angles theorem, we're trying to prove alternate interior angles are congruent. So, again, we're going to say that L and M are parallel lines cut by T, which is the transversal, and we want to prove that angles 3 is congruent to angle 6. So angle 3, we want to prove that this angle right here and this angle right here are congruent, the alternate interior angles. Now we're proving this generally so that we could also show that angles 5 and 4 are also congruent, because those are also interior angles, alternate interior angles. So let's make our two-column proof. So I have my two columns there for statements, and then for my reasons. Start with what you know. What we know is that L and M are parallel, and that is given to us. That's given to us in the theorem itself. The theorem states that. Okay. Now let's talk about what we know. So the thing is, we have proved, let's look to our previous theorems. So corresponding angles and vertical angle theorems. These will help us in proving that this theorem is correct. So let's use angle 3. What do we know that angle 3 is congruent to? Well, in the previous theorem, we proved that that vertical angles are congruent. So what I know is that angle 3 is congruent to angle 2. That because they're vertical angles. So let's write that down. I know that angles 3 is congruent to angles 2, and I know that because they are vertical angles. And vertical angles are congruent. I could probably give myself a little bit more space between these. Okay. Now, what do I know that angle 2 is congruent to? Thing is, from the corresponding angles, remember, corresponding angles are also congruent. So let's see. So angle 2, what are the corresponding angles to angle 2? Well, angle 2 corresponds with angle 6, right? That's the definition of a corresponding angle. So angles 2 and angle 6 are corresponding. And from the postulate that we had before, we know that angle 2 is congruent with angle 6, and that's from the corresponding angles. Postulate from corresponding angles. Well, look at this right here that we just created. Angle 3 is congruent to angle 2. Angle 2 is congruent to angle 6. Now, there was a property that we covered in 6a, if I can find my notes from that, which was the transitive property. If angle A is equal, or in this case, if A is equal to B and B is equal to C, then A is equal to C. That was the transitive property. Okay, so angle 3 is congruent with angle 6 through the transitive property. And there you go. We just proved that angles 3 and angle 6, which is what we wanted to prove. We wanted to prove that angles 3 and angle 6 are indeed congruent. Thus, we proved that these alternate interior angles are congruent. Now, through a similar argument, we could also say that angles 4 and angle 5 are congruent. But we already proved, the reason why we proved this theorem is so that we could apply it generally to any alternate interior angles. Okay. Alright, that does it for this one, and in the next one we'll cover alternate exterior angles.